Section 2 of Chapter 7 starts on page 366. Yes, we are going to go backwards. We did Chapter 9 on purpose, especially the first half of 9 before the ACT, because the ACT did have some of that stuff on there. Okay? So we are going to go back and do Chapter 7. We'll be testing on 7 like by the end of next week. It's this fast. It's a short chapter. It is only 3 sections. Okay? So we are going to be done with this chapter very, very soon. Now, today I'm going to go through the first half of 7.2, and then Monday I'll go through the second half. I will break this into 2 days. But again, it's a short chapter. Okay? So, here's what you're going to be graphing. Okay, on this particular thing, we're going to look at what we call rational functions. Now, just so that you guys have an idea about what's rational and what's irrational and whatnot like that, the definition of rational basically just means you can write it as a fraction. Irrational is where you cannot write it as a fraction. Does anybody know a number that you cannot write as a fraction? Zero I can put over 1, and therefore it's a fraction. Any whole number I can put over 1 and it looks like a fraction. But there's a number. Specifically, we did it last chapter. We had it involved in last chapter. It's not on the board anymore. But last chapter you had a symbol. Pi. Pi itself cannot be written as a fraction. We use 22/7 sometimes as a fractional equivalent, but it's not actually a fraction. That number never repeats. It never stops. Rational functions are numbers that you can write as a fraction. Okay? So the first type that you're going to look for is you're going to look at, this is the type that you're going to see. You're going to see f of x equals 1 over x. This is your parent. You know, I've been using that before. We are going to talk about things today about shifting. Left to right, up and down, all that kind of stuff. That's not going to go away. That's not anything new. All the different transformations that we've talked about from day 1 till now still are there. If it's adding or subtracting outside of it, what's that do? Up or down. What if it's inside? Left or right. That's all we're going to focus on today is what happens when we shift up or down, left or right. Tomorrow or Monday, we'll add more into it, but that is exactly what the parent looks like. This is, and you can graph this with your graphing calculators. They are an option for you to graph. Now, some of the parts of it, though, especially depending on the age of your calculator, if you've got an 83, might look a little bit different than an 84. But they are the same things. I'm also going to refer to a word called asymptote. Remember me using that word when we did the secant and cosecant? Those are the vertical lines that I put in there. An asymptote is like a line that's not really there, so it like rides right up to it, but never crosses it. I use the invisible fence like for a shock collar in that as an example of that. One of the things that I also have used in the past is, have you gone to the zoo? One of the exhibits at the zoo is the wolf den, right, in the North American part, where if the wolf is out there and they're actually moving around and not just laying down sleeping, where are they going? Out in circles. Where? Right along the fence, like stalking you, right? It's kind of creepy that way, but they're going around the fence. They've worn a path through that. I don't know if you've noticed that. It's very similar to that where it's going to come right up to it, but it can't actually hit the fence because if it does, zap. Okay? So that's what the asymptote does. Okay? Okay, so for this particular purpose, here's the first one I'm going to ask you to graph. Now again, you are able to put this in your graphing calculator. And you can put it in as it looks. How do you type a fraction bar? Huh? What is it? Divided. Right. So you just use the divide sign. So when you type this in, you're going to type in 4 divided by x. So there's my set of axes. What does it look like? For those of you who actually typed it in, what does it look like? Like, what do you mean? You guys are doing like this at me. It's like two different things. That's not it. That's not it. Does it look like that? Or something to that effect? Okay. Now, a few chapters ago, do you remember how we did exponentials? And how it looked like it was going right alongside that, and then all of a sudden went real sharp up or real sharp down? It's very similar to that in a sense, but there's two parts. Hyperbola is what this is known as. Okay? So when we have two different parts like that, I want you to identify, where does it ride? What line is it riding along? The x and the y-axis. Right. Those are the asymptotes. So how do you label those as asymptotes? Well, I put asymptotes, and this is how you spell it. And I put y equals 0, x equals 0. Those are asymptotes. Those are the invisible lines that they're going to ride along. Now, here's something that I want to point out with the 83s. Once we start shifting to the left or to the right, here's what's going to happen. The 84s will not draw this in, but the 83s, Bryce, will. Okay, Bryce squareds. Your guys' 83s will draw this in. It will try to draw the asymptote in because when they were programmed, they were trying to connect the very bottom point with the very top point. So they were trying to connect the very lowest point down here with the very top point up here. So when you do one that's been shifted, you're going to see this vertical line run straight up and down. That's not really there. Okay? Bryces? 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 Okay? That line's not really there. So, as far as what they do for this one, it says to draw it. How do you draw where I put the black curves on there? How did I get those? I just kind of roughed it in, right? Now, something that I'm going to ask you to do, I'm going to ask you to label the asymptotes. So, putting the asymptotes as far as putting me having x equals 0, y equals 0 on there, that's something important to me. What else I'm going to have you do is I'm going to have you label the intercepts. Is there any intercepts for this one? No, because it rides alongside of it. Something else, though, would be compare it to the original. Okay? Here's the comparison to the original. The original graph was 1 over x. So what's different from 4 over x as compared to 1 over x? I don't know. What's difference? Not 3. There's no 3 on the board. What's the difference? Don't actually subtract them. What is like a similarity and difference? One's a 1, one's a 4. That's what I'm looking at. Okay? Not 3. Don't subtract them. I'm not asking for the difference. Sorry, I know it's a math class, but I'm not asking for what's the difference. Like the difference between Angie?
Yeah.
Abby and Sierra, one's wearing green, one's wearing pinkish. Salmon. Whatever. Okay? That's what I mean by difference, not subtraction. So this one's got a 1, this one's got a 4. So for this particular, there you go, compare and contrast. Thank you, Allie. Okay? So for this particular thing, the change from 1 was, 1's a 1, 1's a 4. Guess what that did for us? That is a vertical stretch by 4. How did I get that? Because it went from a 1 to a 4. How did I know it was vertical and not horizontal? Because it's on the top. Okay? If it's on the top, that's being multiplied on the outside. Okay? If the number is different on the top, that's vertical. Okay? If the number is different on the bottom, that's horizontal. So if there's a number being multiplied to the x on the bottom, that's horizontal. Top, that's vertical. And here's how I can show that why it works like that. That's the same as me saying 4 times 1 over x. Because when I multiply fractions, it's top times the top and bottom times the bottom. That's how I can prove that that's the way it was. So if the number changes on the top, it's a vertical stretch or shrink depending on the number. Okay? And now if I throw that in there at you, okay, here's what I'm going to suggest as far as typing this in. If you want to type this into your calculator, it is possible. However, here's what I would do for you on this particular concept. I would do parentheses 3 divided by x, close it, minus 2. That will give you the appropriate graph for that. Okay? So, as far as graphing it goes, what does it look like? All right, so it looks kind of like the same thing except for what's different. It goes down a little bit further, right? How far down do you think it went? 2. How'd you get that? This right here means down 2, doesn't it? When it's on the outside like that, that means down 2. So here's what I do. I'm drawing this for the first time. I've seen some of your calculators because you said this is what it looks like, and you're holding it up. And that's awesome. But at the same time, here's what I do. Normally, the parents' asymptotes are the axes. But this time, you shifted everything down 2 units. Which means 1, 2. I'm going to make a dashed line. Does the dashed line really exist? No. It's just there for a reference. Did I shift it to the left or to the right? No, I did not. And what did it look like again? Ride, turn. Ride, turn. Is that about what it looked like? Okay. Now again, I put that asymptote on there. I had an asymptote at y equals -2. How did I know it was at -2? Because you went how far? Down 2. If you abbreviate asymptote, I would assume I would be all right if you put ASYM. Try not to put too few letters, because then all of a sudden you're swearing at me. Really? Okay. What else changed with it? Is there any other thing that happened? You said down 2, and that's awesome. But what else? Huh? No, not x equal. We didn't move it to the left or to the right, did he? We also had a vertical stretch by 3. You were close, Allie, actually. You weren't running it right, but you were really close. Okay? We had a vertical stretch by 3. Where'd that come from? The 3 on the top. Right? You're done. Okay? Now, the only other type that you're going to see, what happens if they give you one like this? G of x equals neg 4 over x plus 2 minus 1. There is actually 4 different transformations that are taking place. Okay? Tamara has spoken. And she said left 2. Why? Nice job. That's awesome. And if you didn't hear what she said, because she's kind of soft-spoken, she said the bottom is kind of like in the parentheses. So when it's in the parentheses and it's adding, you shift it to the left. That is 100% accurate. What else? Down 1. Where'd you get the down 1 from, Zach? The minus 1 on the outside. Awesome. What else do we got? We have a vertical stretch by 4. Not negative 4. Remember, negative sign's its own. And the negative sign does what? Over x-axis. Remember, it's on the when it's on the top, it's like it's on the outside. Okay? So those are the 4 parts that we have for that particular thing. None of that's new. All of that's been kind of review for you guys for everything we've done. Now, I'm going to take that and I'm going to draw what I think should happen. I have no idea, and some of you guys may have even typed it in wrong, because we got to talk about how to type this one in. But when it says left 2, I'm going to put an asymptote, then left 2 spaces. 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. That's at x equals negative 2. When you said down 1, 2, 2, 2, 2, 2, 2, 2, 2, 2. I'm going to put an asymptote at y equals negative 1. Make sure you label those. That's going to be stuff when we get to the test that I'm going to be looking for. Label your axes, or label your asymptotes. Now, as far as what you also said, you said a vertical stretch, which means we're going to turn it. You also said reflect over the x-axis. Well, originally, this was going down here and here, but you said reflect it, so instead of going this way, you're going to go that way. All right. So I should come, right, turn. Right. Oh, can't do it. Can't. Right, turn. Is that about where it looked like? Yeah. Now, here's how you type it in. Because some of you guys are going to type stuff in wrong with these. I've done it too. So don't be ashamed if you did. When you type this one in, here's how I would do this. One of the things, once you go to y equals, you could go, a lot of times what I like to do is I like to go negative 4 divided by parentheses x plus 2 minus 1. Now, do you know why I put the bottom in parentheses? Okay? If you don't, and if you look at the board just for a second, if you were to type it as negative 4 parentheses x plus 2 minus 1, what's the calculator going to do? The calculator is only going to do this part of it for you. Then they're going to take 2 plus 1 or 2 minus 1 and give you a positive 1 there, not what you need. It's not right, because it will do the division first before it does the adding. Does that make sense? Mm-hmm. So when you have stuff in your top and in your bottom, make sure you put it in parentheses, and then it will alleviate all question. Then it will be right. These are the only types that you're going to see today. Only the ones that shift left, right, up, or down. Okay? Are you guys comfortable with it? Yeah. For now? All right, so on page 370, we're going 4 to 18 evens.